I always have a few things to talk to people about. And, I think it's important for us to think about what we think about in our recent history. And it's always struck me as very surprising how stupid we were 100 years ago. So if we were to pop over to the screen here. 100 years ago, nobody believed in atoms. That Ernst Mach at Vienna was convinced that atoms did not exist, that we were really interested in looking at energy states. And it was only through the influence of Einstein that our current model of the atom became more popular. And 100 years ago, we didn't believe that much completely in evolution. That although Charles Darwin published his first edition of The Origin of Species, and that's the one that, if you ever get in with the evolutionary psychology people in our department, oh, we really love that first edition. But in subsequent editions of his book, he kind of backtracked a lot and went into something called Lamarckianism, that people could inherit characteristics of skills that the organism had adapted. And it wasn't until a few years later that we actually started to think about these things called genes and understood genetic transmission. And I guess also for me, it's amazing to me how much bigger the universe has gotten in my life. When I was going into school, we knew that our solar system existed, the Milky Way galaxy existed, and there was this thing called Alpha Centauri that was another galaxy a ways away. But at the end of it, they said, well, that's it. And everything else that you see out there is dust clouds and, little foggy things. And the size of our universe has now expanded many, many times over again as we realize that those dust clouds are in fact other stars, other galaxies. And we know a lot about the history of technology. So if you think back 100 years ago and how stupid we were, within 50 years, many of the things that we currently believe are going to appear equally stupid. Just a little food for thought. Let me come back to the PowerPoint here. I had a suggestion from somebody during office hours that I should show the slides this way so we can talk about the notes down here at the bottom a little bit. And honestly, I'm sitting here at a one monitor screen, so this also helps me to remember the notes that I had for a bit. And while I'm at it, let me open up the chats here, or if someone does, come here. Chat room in case people have things to say so I don't lose sight of that. So we're going into chapter 5 here. And this one is going to be about identifying good measurement. Chapter 5 differs a little bit from chapter 4, which talked a bit about research, in that we're going to get into the words and the ideas that we talk about when we think about measurement. Now, measurement is, a lot of people think, I don't like psychology. I don't really care about measurement. But the issue on this is that really how you measure and what you consider a measure is pretty much a really key part of understanding some research. Now, this is a slide that comes from Norton. You can tell by the little flying seagull in the upper hand corner. So in the book, they talk about, what's the happiest country in the world, or can money buy you happiness, or is gratitude for lovers? And those are very interesting ideas. But what do we actually mean by happiness in all of these three situations? And what do we mean by gratitude in people being in a productive relationship? So here's where our idea about a variable and the operational definitions comes into play. You could talk about gratitude toward your relationship partner, and you could say, do you agree that you appreciate your partner? And that's going to give you, questions like that are going to give you one set of insights into the strength of the relationship the person is in. Another way of looking at this, though, is to watch couples interact and count how many times say that they thank each other. Now, each of these operational definitions may be open to different criticisms. So if you have been in a long-term relationship, say with your parents or with a romantic partner, there's probably some gender differences going on here in how they rate the relationship. One of the standard chestnuts I'm fond of noticing is, men say they tend to help out around the house a lot. And women, on the other hand, say, well, no, actually, there is no such thing as a clothing fairy. I do an awful lot of work around here, and he's not doing that much. I am in kind of a non-traditional relationship, and I would also say, in fairness, that when I go away on conferences, afterwards, my wife is grateful because, like, oh my gosh, there's a lot of things that happen around here. And I don't pretend, though, that it's half 50-50, though. So there might be some problems in asking, do you appreciate your partner? Because they might think they do. They might think that there's an implicit part to that, but they may not actually be showing it. And actually watching people could help. Similarly, watching couples interact and counting how many times they thank each other, that could have some problems too. I'm from the Midwest. People tend not to talk very much. However, they do. So maybe counting how many times they thank each other isn't your best idea for showing what's going on with being gratitude. But if you do things, that also sends a message. Gender identity. Asking people to report and whether they identify as male, female, or non-binary. And in a phone interview, you can guess through the sound of the person's voice. Well, those are two different things going on there. And they are subject to their own problems. Asking someone to identify as male, female, or non-binary itself has some issues, because in some situations in our society, they don't even understand what the phrase non-binary means. And, I would hesitate to judge a gender based on, say, the sound of a person's voice over the phone. I don't know why, but, it really kind of annoys me when I'm talking on the phone to someone and they say, oh, sweetie, could you speak up? I can't hear you. So, it's not entirely a valid way of looking at things, but, those are operational definitions. Wealth, you can ask them to report their income, or you can, and each of these values as well may have their own problems. So if you're looking at asking people to report, sometimes they don't want to report. If you're looking at a car and maybe looking at the status of the car or the age of the car, that also systematically rules out the fact that there are some of us, say the disabled or handicapped, who don't drive cars, or people who live in towns that use public transportation. Are they necessarily lower SES because of that? Intelligence, we can give an intelligence test, problem-solving items, memory, vocabulary questions, puzzles. Frankly, you have all taken intelligence tests, although we're suspending them at MU due to the COVID problem, because ACTs and SATs are pretty highly correlated with general verbal intelligence. Another way of looking at intelligence is to give people a problem and see what parts of their brain light up and how much frontal activity is going on there. And well-being, you can ask them about the ladder of happiness, or you can give them the 5-point subjective well-being scale. So, there's multiple ways to define this. And I guess my take-home point, going back to the little stories that we have here, is each of the operationalizations that you have of, say, happiness or gratitude have their own problems. This is an example of an fMRI study, and I think it's kind of fun to talk about that. So what you're looking at here are various sides and cross sections of the brain, and the coloration that goes on here are the differences in coloration when people win versus lose in playing rock, paper, scissors. There's a little bit of an issue going on here. And when you're looking at, it seems someone who's 4 inches tall is going to make a lot of noise this morning, I'm sorry. When you're looking at these pictures, how you decide what to light up is kind of a judgment call. And secondly, how we model brains across different kinds of brains is also somewhat of a judgment call. Mathematically, if you're looking at how people actually model the brain in terms of aggregating data across, we kind of think of the brain as a balloon with sort of standard sizes and so forth across people. And that may not actually be the case, particularly in the case, if you're looking at my face, you can see I have a scar that runs up the left-hand side of my forehead. There's a little bit of different brain activity going on as a result of that car accident when I was a kid. Now, here's some terms here. When we're talking about measurement, we can think about categories of measurement, a categorical variable. You might say, what kind of music do you like? What's your favorite color? What's your nationality? What kind of phone do you use? And there's no ordering these things. I mean, maybe you can order music in terms of loudness. God knows with my son's music tastes, that's certainly an ordered category. But generally speaking, they're just different colors. And there are 3 types of quantitative variables. So let me stop the share here for a little bit and talk to you about them. I don't like the way the author introduces these things because the easiest thing to understand is a ratio level measurement. Here's my prop. This is a ratio level measurement. It's got a meaningful 0 point. So if I have nothing of length, I get a score of 0. And as I have measuring units, they're all equally spaced. I've noticed that actually these days, they even show you the darn little fractions in there. Ratio level scales are useful. You can measure growth. You can measure square footage. You can measure none of something. And, you see them every day. So being from Iowa, if you want to measure how tall a corn stalk is, you get out there and you use your trusty tape measure. You know about knee high by the 4th of July. Now, this is the second measuring tape I bought. Have I told you this story before? Probably not. And when my son was young, 6 years old to be exact, they just find these measuring tapes fascinating. So I was working away and he got a hold of the tape measure and, you pull it out, you snap it back, you pull it out, snap it back. I said, Justin, can you stop that? That's not a toy. Oh yeah, Dad. No, I know, I hear you. And then after a while, I went, oh crap. Well, I was then the proud owner of a measuring tape that starts at 13 inches. Now, is that measuring tape useful? My son, in breaking my measuring tape, changed my ratio level measurement into an interval level measurement. I can still measure how tall things are if my measuring stick starts at 4. I can say, well, this is 2 inches longer than that. But if I try to use this measuring tape and calculate square footage, I'm not going to be able to do that. And if I have none of something with my broken measuring tape, I'm going to be recording the number 4 instead of 0. So in psychological measurement, when we treat something as an interval level scale, we're saying that the measuring units between the units are the same length. So in this case, they're inches. But a 0 on the scale does not necessarily constitute none of something. It could actually constitute something. So you've all taken, for example, questionnaires that have 5-point Likert scales. Well, are you supposed to score it 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, or -3, -2, 1, 2? Well, I should, 5 points don't split with a meaningful 0 point, but you get my drift. And the scaling, the assignment to the numbers is arbitrary, but your 0 point, can be any old number, but the amount of change from 4 to 5 or 3 to 4 or 2 to 3 is always the same units. So that's an example of an interval scale. And that's where we think a lot of, when you calculate correlation coefficients between two variables, you are assuming that you've got an interval scale going on. And I'll have more to say about that when we play with scatter plots. Well, what's an ordinal scale? Well, an ordinal scale is, to me, the hardest thing to understand, because an ordinal scale is a measuring tape where the numbers are not equally spaced. So if you had to go a short way to go from 0 to 1, but a really long way to go from 1 to 2, that's an example of an ordinal scale. You've done lots of ordinal scales in your life. Teaching evaluations being one example. It's really, really hard to get a 1 on a 5-point Likert scale of teaching effectiveness. You have to be a gold-plated, arrogant jackass. And this is because so long as you try to teach, students will generally give you the benefit of the doubt. Don't go off getting ideas, you got to give a 1 to me just to show me that. But generally speaking, scores on teacher ratings run from the midpoint of 3 to 5. So probably there are lots of gradations of teaching effectiveness from 5 all the way down to 3. But if you're going from 3 to 2 to 1, those units are probably different. Probably the person who is a 1 on a 5-point scale of teaching effectiveness is really, 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 really bad. And probably the distance from a 5 to 4, or even from a 5 to a 3, is not that great as from 3 to 1. Okay. Now, when we're analyzing things in ordinal data terms, calculating a correlation coefficient is a little problematic. You kind of hand wave a little bit. When you're looking at correlations, you are really thinking of your data as being at interval or ratio level. So if we were to come back to our little value here, essentially what I wanted to do is to talk about things in the reverse order to what the author has. They're equal distances, and a 0 represents none of this. I'm not that hot on her example of the number of exam questions being answered correctly, because I don't think that if it's a multiple choice test, that the number of exam questions answered correctly is a ratio scale. It doesn't take into account, for example, the fact that you can guess. So it's really, really hard to get a 0 on a test, because so long as you answer the items, odds are you're going to get a right answer sometime. And conversely, a value of 0 doesn't mean you have none of something. So if you're giving somebody a verbal ability test and they score a 0 in recognizing words, does this mean they have 0 verbal ability? Well, no, they probably know some words, just not the words you asked about. But how many episodes of a show you watch, or your height, you're measuring, the measuring tape, that all agrees a ratio scale. Interval scales, your score, your shoe size, how much you agree with something on a 7-point scale, we often treat as interval. And then ordinal variables, order, ranked choice voting, or what do you like versus what do you not like. And frequently, if you're playing with higher order statistics, we take into account a 1 to 5 Likert scale, and we have some math called latent response variables that allow us to analyze the data as if it's ordinal. So those are terms, add those to your vocabulary, and those appear on page 148 of the book as well. It helps for us to talk a little bit about correlations. It looks as though from the test that most of the people know what's going on with correlation coefficients. One example of reliability is to take a measurement and turn around and take a measurement again. So in this particular case, on the ordinate, that is the up and down the y-axis, we have one measurement, and then we have a second measurement on the x-axis. And we see here that we have a really high correlation between these two variables. So this is an example of what is called test-retest reliability. So we give people a test and we turn around, we measure them again. We say, do we get kind of sort of the same values as we had across our two measurements? Now, that's going to be useful in some situations and not so useful in other situations. So if you're looking at attitudes, say racism, or dogmatism, or life satisfaction, maybe you would want to see a test-retest correlation be high and say, well, these numbers are I'm kind of getting the same numbers if I turn around and give this instrument again. In other situations, when you're looking at growth or learning, maybe a test-retest correlation isn't the most informative thing you can have because different people are learning different things as they take the class. So, it's a little bit of an issue to think about, well, yeah, I've got a test-retest correlation coefficient because I gave my instrument twice, but is that necessarily going to tell me, is this instrument giving me the same information across both times? Because sometimes people are changing. Now, a small note here, when you're looking at whether you're examining two measurements that are a ratio scale or an interval scale, is if you have a ratio scale, you would also be interested in the question of whether this regression line, this green line, goes through the origin, through the 0 point. If you've just got two measurements and they're an interval level scale, you'd be interested in the correlation coefficient, but you might not necessarily be interested in whether this regression line goes through the origin or not. And that's because maybe they're interval scales, but the ruler got broken one time a little bit differently than the other time. And you can measure the head circumference. You can kind of take a look at those data. If you're doing your measurement, probably it's kind of interesting to take a look at do you agree on the highest person and do you agree on the lowest person? And it seems that the book assumes that you've never seen a correlation coefficient or a scatter plot before, but this figure makes the point that if you've got very little scatter around the regression line, you have some fairly good inter-rater reliability, and if you don't, you'll have a lot more scatter around this. So in this particular example, we've got one observer and another observer across two times, Mark and Matt. And here we have one observer, Peter, and another observer, Mark, and there's a lot more scatter. So they're not really agreeing on who is, got, I think in this case, it's happiness ratings across the two. So sometimes you've got high inter-rater reliability, sometimes you have low inter-rater reliability. And again, often in work, in this particular situation, it kind of also looks like this regression line indicates that you've got maybe a ratio level scale because you've got the regression line going through the 0 point. In this case over here with low inter-rater reliability, it doesn't go through that. So even if you're going to even say, well, I'm still going to use this as a measure of inter-rater reliability, it doesn't go through the origin. They're probably only interval level scales at that point. And they talk a little bit about, inter-rater reliability, but I walked you through that. The book again puts us through what looks like a positive and a negative and a high and a low correlation. This is a time, we've gone through these before, but this is also a little bit of time to kind of think about, if you're looking at a scatter plot, how might you reason about that? So remember, when we talked about a regression line, that a regression line through a lot of points is the line that gives you the least amount of variation in the vertical distance between these points. And when you're looking at a scatter plot, you might sort of interocularly just kind of take your fingers out and squeeze between these data points and kind of make a little data point in the middle of that cloud of data points and then draw a line with it as an informal assessment of whether the relationship is linear or not. As we're going to see, not all relationships are going to look like this bivariate normal distribution. Sometimes things are skewed. Sometimes you don't have a lot of observations at high endpoints of the scales when you're looking at depression. So here's our positive correlation. Here's a higher correlation, our 0.93. Here's a negative example. This observation down here with a small number of observations might actually be thought of as an influential observation. You're probably going to get a different regression line with and without that person. And here's a 0 correlation example. Sometimes, as I mentioned, you can't really retest, reliably assess, and sometimes you don't have multiple observers to look at the data. So what we're going to do is to treat the individual items of our survey as raters, as giving us some information. And this is a table from the book. And she's looking at Diener's scale here. And what she's trying to do here is to make the argument that you can take a look at correlations and sort of eyeball what items are not part of that construct. So you'll notice items 1, 2, and 3, those have nice correlations. And item 5 has some nice correlations as well, but not again with item 4. So if you kind of shoot across item 4 and then go down, you see all those correlations are 0. So I am fond of polka dots is probably not going to be related to items dealing with how satisfied you are with your life. Now, to be honest, these correlations for these 4 items from Diener's scale are pretty representative of what you would see in a lot of social psychology. In my area of research, I would look at those correlations and I would be a little bit skeptical. When you're looking at a table of correlations and you're kind of trying to make some guesses about reliability, for reasons that I won't go into here, but I'll give you this little clue. If you look at the correlations and you take the square root of them, that's kind of a guess as to what the coefficient alpha, or what the book calls Kronbach's alpha, is. So just kind of looking at everything but item 4, I could say, well, 0.25. 0.5 times 0.5 is 0.25. So if I was kind of thinking about what reliability should I kind of see, I would expect maybe a number close to 0.5 based on this. Oops, down here I've got this 0.4. Well, 0.6 times 0.6 gives me 0.36. So, maybe it'll be a little bit higher than 0.5 based on the fact that this one was a little bit higher. Now, the funny, weird thing about that is that this example cites an article. And let's come back up here and refer to the article that's in here. And this is an article that explains that maybe you would like to calculate the average correlation in your items as a way of understanding reliability. And when I looked at the table here, I thought, well, gee, 0.5 is not a very good reliability for me. And if you go back to the article, and let's see, come down to the 5th example of it, the authors of the article that she cites kind of agree with me that you probably want to have coefficient alpha, or the reliability, being around 0.8. And if you see people reporting coefficient alphas of 60s and 70s as good or adequate, that's probably not a really great reliability. 0.8, a reliability coefficient means what proportion of the variance in your data is due to the latent variable or the construct that you're measuring. And that's kind of saying, can I at least be confident that I've got 80% of my variation being the thing that I want to measure? So a reliability of 0.5, as shown in this PowerPoint, is you're only explaining half of the variation in the data based on the items that you're asking. The original article, and I give you a link to it, is a nice one in that they make the point that the longer you have a scale, the more reliable that measurement is. So to some extent, any old thing you want to assess, you could probably get to an acceptable reliability if you give people enough questions on it. After you take into account the fact of participant fatigue because they get tired filling out your 300-item survey that measures one thing. And so often the average correlation among your items is an informative way of looking at the quality of the items regardless of the length of your survey. Now, the book does not go into this, but this is kind of this article does go into these points. So I'd like to talk to you a little bit about the way we actually do things. You start with a bunch of items. Very often these items have been generated sitting around a table. I don't know, what do you think life satisfaction means? Let's put an item in that phrases the question this way and that way. And the very first thing you want to do is to ask the question, am I looking at one thing or am I looking at two things? Am I looking at one construct of life satisfaction, or am I looking at, say, one life satisfaction construct and maybe a general optimism construct? And there's this thing called factor analysis that we use to uncover how many latent variables, how many constructs there might be running around in the data. Because reliability is a different thing than how many constructs are you actually dealing with. So, factor analysis is usually our first step, and we organize our items into groups. And we'll be talking about an example of that later on with the example that's mentioned in the book on relationship appreciation. And step 2 then becomes, okay, now I have a bunch of items, and those items are in a family together, and I then look at that subset of items, say 10 items, and say, this is reliable. So those are kind of two steps. And there's a link here to this paper that will actually skip around a little bit, and I'll show to you. I don't want you to read the entire article, but I do want you to have a sense for how we actually do things. Here's an example of a table where we're looking at reliability across a variety of studies, and coefficient alpha, that's a measure of internal consistency. So if we use the individual items in our scale, what proportion of the variation in those items is due to the construct I'm looking at? And here's a test-retest reliability. So I gave the people my test, and then in this case, 2 weeks later, I gave them the test again, and I have a really nice reliability. As we mentioned, the longer you space your tests, the lower the correlation. So if you test people 10 weeks later, in this particular sample, the correlation was only 0.5. And if you look at people 4 years later, the correlation is 5.4. Remember in a previous lecture, I talked about the issue of shrinkage. So when you're looking at a scatter plot with only, say, 6 or 10 observations in it, you're going to get a big correlation because regressions, because correlations capitalize on chance. And if you have a larger sample, if the real correlation is not a high number, you are going to observe a very low correlation. So to kind of rehearse that point, because the book doesn't talk a lot about it, if I do 10 observations and I run up my study, I'm going to get, it will not be unusual for me to observe a correlation of 0.8. However, if I start gathering hundreds of observations, that 0.8 correlation, even in the same population, may go down a lot to something like 0.3. Well, the same thing also happens with coefficient alpha and test-retest reliability. If, for example, Alfonso and Allison 1992A is based on, say, a sample size of 50, that coefficient alpha and test-retest correlation are not nearly as impressive as if they would be looking at hundreds of people. It might be kind of useful to go in and take a look at the Pivot and Diener article. Actually, they had a whole bunch of studies that they were looking at. Look at all of them. You know, they studied a lot of college students, and here's their means. College students, you may be surprised to learn in the present environment, are generally happy and satisfied people. You know, we have Scottish people who are not terribly happy and Chinese people who are not terribly happy students. However, we also have other samples as well. Prison inmates, doctoral students, even though doctoral students sometimes tell me they feel like prison inmates, actually their satisfaction is pretty comparable to that of other students. Abused women was a bit of a surprise to me, 20.7. That might point to, why is that? Are these abused women getting out of a bad situation, or are women in general, we don't really know the sex of these other samples, are they more likely to say they're satisfied? So, you know, it was a really large sample, and you know, here's the table you just got done looking at, and they have a lot of discussion about the fact that sometimes in studies your scores will increase over the course of time, you know, just because the people are changing over the course of time. So that's an illustration of what I was talking about before, that actually test-retest correlations are not the be-all and end-all of things, because it could be that some of your people are changing in their scores over the course of time. So measurement. Reliable measurement is not necessarily valid measurement. And this is kind of a funny picture that, this person gets on their bathroom scale. It reports that he weighs 50 pounds every time he steps on it. That's a very reliable measure. It's probably not a valid measure of his weight. And way back in the day when I was in school in Iowa, they didn't think that students in Iowa would be going on to college. So our aptitude testing that we had was, how manually dexterous were you? And you'd screw nuts and bolts on things and assemble small apparatus in a certain amount of time. And they would score you and they would say, well, you probably would be a very good factory worker. Well, yes, those measurements were probably very reliable. I remember one that was a bunch of paper clips in a dish on the left-hand side, and you would just pick up a paper clip and put it in a right-hand dish as quickly as you could. Very reliable measure, but is that necessarily valid in predicting who's going to make a good factory worker? Sometimes you can take your measurement and you can make some tests of whether that measurement is valid. So I have a little Garmin thing. I used to have a Fitbit. Your phones will also count your steps. How could you tell if it's accurate or not? Well, you can conduct very small tests. You can walk around a little bit and look at how many steps you have and get an idea of whether the step count is actually accurate. Here's a little chart of some of our language about construct validity. So let's kind of walk through this. I hope I can make this a little bit bigger. There's two subjective ways to look at construct validity. There's face validity and there's content validity. So these two parts of construct validity are subjective. They are judgment calls. Face validity is really not a formal statistical test at all. It's looking at the items and saying, hey, do these items look like they're reasonable items? Now, at the end of the day, there could be some problems with that. And the question you have to ask is, whose face is doing the examination of the validity? When you publish an article, probably expert reviewers will say, do these items look like they're valid indicators? However, and the book doesn't really talk about that, to me, another important part of face validity is asking the people you are assessing. Because the people you are assessing may know some things about whether your items are valid for their population. Is it a fair thing, for example, to judge children as being more or less literate or more or less intelligent based on whether they can match farm animals to the sounds that the farm animals make? Probably a good measurement for a child who's growing up on a farm, but probably not that great of a measure for a kid growing up in an urban environment. Or to draw another example maybe you can relate to, for an awfully long time, early childhood assessment had items on it like, what do you do in the bedroom? Well, we sleep in the bedroom. Fine. What do you do in the dining room? And I remember, this is way back when tests reigned supreme, you took the test in Iowa, and then afterward, the teacher went in front of you and said, okay, class, this is the item that most of you got wrong, and let's go over why you got it wrong. Well, none of us ate in the dining room. We all ate in the kitchen. What are you talking about? And these days, if you ask things like, what do you do in the bedroom? Well, we've got our electronic devices, we have our televisions, we have all kinds, and some of us eat in the bedroom. Those items are not necessarily indicative of a child's report in response to the question that the test maker thinks they're asking. Content validity is another subjective call that, maybe a reviewer of your paper would say, well, you asked about these and these parts of verbal reasoning, but you didn't ask about those. And if you don't sample the content areas that you have, maybe your instrument is not going to be that good of a measuring tool for what you have. Now, the book doesn't talk about this, but subjective ways to assess validity are not necessarily going to be informative. There might be instruments that everybody says, oh yeah, that looks fine to me. But really, if you start to look at how reliable it is, maybe it's not going to work very well. And secondly, sometimes there are measurements of a construct that are not face valid, but are actually highly reliable. So maybe you come into a doctor's office and you complain of breathing problems. And the doctor conducts a diagnostic test for emphysema. And that diagnostic test consists of show me your elbows. Now, that does not seem like a very valid measure of emphysema, does it? Face valid. But it works quite well, actually, because people with emphysema have had emphysema for a long time. And when people with emphysema are trying to breathe, they often put their elbows on the table in an effort to straighten themselves up so they can catch a breath. So the presence of calluses on the elbows is more indicative of a long-standing breathing problem than, say, a breathing problem that might be due to the short-term intervention of COVID-19. I never get through as much of these things as I think I ought to. So let's turn now to empirical ways to look at validity. Well, over here on the right-hand side, you see reliability is an important part of this. That in order for us to have something that hopes to be valid, if I do my assessment again, or if I look at parts of my assessment, I hope that those numbers kind of hang together. And looking at that, we have test-retest reliability. That is, if I turn around and give my instrument in, am I going to get the same number? Similarly, do I have inter-rater reliability? If I ask people to look at, say, the number of aggressive outbursts in a classroom, would people rate that the same? And do I have internal reliability? That is, if I ask multiple items in my assessment, do those numbers tend to hang together? But at the end of the day, reliability doesn't establish validity. It's kind of a necessary first step. And I have to think about whether I want to see these different types of reliability or not. So if we walk back here and say, well, test-retest reliability, I just talked about the fact that if your people are growing or learning or changing or their condition is worsening, test-retest reliability isn't going to necessarily be the best way to assess reliability. And similarly, if I'm looking at raters, maybe inter-rater reliability isn't the best thing if some of the raters are good informants and others are not. So my wife did her dissertation on aggression in girls, Black girls in Jackson, Mississippi. And ratings of aggression are not necessarily going to correlate well between students and teachers. And this is because the teacher doesn't see all the aggression going on, but the other students do. So in that case, the invalid ratings of the teachers are a reason that teacher and student reliabilities don't agree. Students were quite reliable with other students. And internal reliability is also, if you have the luxury of multiple items in your survey, you can get an estimate based on something called reliability theory that will tell you how you think your test should correlate with another administration of your test. So it's kind of a guess of what test-retest reliability is based on the performance of the individual items. Well, I feel like Carol Burnett, I'm not sure what I need, but we're going to have to call it in for today, and we'll pick this up on Wednesday.